P-vax.
Good. So the probabilities, in this case, they add up to exactly 1. So the sum of the sum of the P of X's is 1, and I'll do half and half here. So that's how it looks in Mathish. And all the probabilities between 0 and 1. So in the front, of course, just to remind you guys, on the other side is a completely worked out problem, which you can reference that. What's the probability that a kid is picked who believes there will be at least 25? Let me ask you this question. What's the probability a kid thinks they'll be 40 when they retire? They will be exactly 40. 23%. Good. So I always have people that can't read this. This is the probability that they said this. These are their answers. How do I know that? Because that's the data. The data is the answers to the question asked. These are their answers, and this is the percentage that said that.
What if they said at least 50?
Are you ready? So now at least 25, what does at least 25 mean? Could they say 25? Yeah. Yes, at least 25 includes 25. Or 25 or over, right? So I'm going to take all these, I'm going to add their probabilities. That'll tell me what percentage of the kids said that. Now what could I do alternately? Didn't I just leave 1 out? Couldn't I also say 1 minus 0.04 and get the answer pretty damn quick? Yeah. That's related to that whole at least 1 is 1 minus none. The probability of something is always 1 minus the probability of what it left out. You could just do whichever one is quicker. Right? So me, I would do 1 minus 0.04 is 0.96 and just, be done with it. Done. But if you add all these up, what do you get? You get 0.9 freaking, of course you do, right? I have to, because I already know all of these make 1. So if I take 0.04 out, the rest of them must make 0.96. That's why it's 1 minus what you leave out. Because they make 1 altogether. Do you have to do it that way? No, you can just add up all this. That's fine. I'll try to lead you down the road. That's a lot quicker. Okay. So I already know this. What's the value of the mean?
45.
Yeah, that just comes right off of there, 45.89. The one that doesn't come right off of there is the standard deviation, the variance. Where do I put 2410.89? I always wait for somebody to go, I'll tell you where to put that, John. Where do I put 2410.89? Probably where I just underlined, because what is 2410.89? It's the sum of these, and that's what this formula needs right there. So 2410.89 minus 45.89. That's the easiest thing to miss. People forget that square there. Poor little mean. It's not fair. You should get squared. The variance is what? 304.997? Okay. And then how do I get the standard deviation? Square root that bad boy. I like it. 9979. Now if I take the square root of that, what do I get? 17.46. 464 is good. 4642 I would take 2. What is it with standard deviation? It has to be at least 3 places. That's all. I'm just trying to save you from rounding too much by making it across the board kind of thing. So if he said 4642, it's even, how could I complain? It's even better. Just don't say 4641890. Oh my God, dude, don't do that to yourself or me. Now, Part D should sound very familiar, right? We have all these theorems and shit about how much data is within whatever. I like these concrete examples. So this should feel very familiar. Put the mean in the middle. Add a standard deviation, subtract a standard deviation. When you add it, you get what? It's like 62 point something. 63 point something? Shit, check. Blah, blah, blah. And then when you subtract it, you get 28 point blah, blah, blah. 4 something. So which data points are caught in there? Yeah, there's no, 25 is not in there. 40 is in there. 40 is like right here. 50 is like right there. What about 65? Nope, it's outside. You do not do 2 out of 6. That doesn't make any damn sense. If you caught all the 40, what percentage did you catch? 23. But we also caught the 50s. So what total percentage did we catch? 41. So 41%. Because we just added the probabilities of those. Now who's got part E? I love part E. You got it. What you got?
828.
How'd you get that?
All I did is the same, we retired before age 65, so I added up everything, 0.04, add all that up, all the way
Okay.
to 50, and then after that,
What'd you get there?
I probably calculated it down.
I'm with you. You got 0.69. Is that? Anybody else do that?
Yeah, 0.69.
0.69.
And I times it by,
Because that's the probability that they said before 65, right? You had this. It's the probability that they said they were trying before 65. Times how many kids there are. And how many kids are there?
1,200.
1,200. How do you know that? So first thing I said. So 69% of 1,200 kids, and whatever the hell that is. Oh yeah, that's right. Forget it. So 828.
Yeah.
I like it. Okay. And again, I know, listen, I get this kind of comment all the time. Statistics is not just about, you guys get so caught up in the details, and I don't blame you because you want to get it all right. That's great. But reminders that we actually talked about why these formulas work. We developed the formula for the mean by starting with the list like we did before. We attacked it the way we normally would, and then we improved it with a lot of repeats. So that's all we did. So we saw where the formula came from. And what situation would I have stuff like this? Well, how many of you guys pay car insurance? Anybody? Or have somebody pay it for you? Anybody? There we go. We got a few more hands. Right? Enjoy that while it lasts. Anybody hit the magic age of 25 yet? An amazing thing happens at the age of 25. According to the car insurance companies, you suddenly learn how to drive because your premiums drop. I still remember that. It was a really nice little present for me. Risk factor, beautifully was said. Risk factor goes down. If you ever saw that movie, Along Came Polly, with Ben Stiller. And was it Jennifer Aniston? It's funny that I remember Ben Stiller. I remember who the hell the girl was. Basically, you take the amount of money you expect to pay out given a certain situation, like for somebody a certain age, and if you look at it, they're like, do you get good grades? Why would they decrease your amount for that? Because students that get good grades statistically are in less accidents, right? Believe it or not, if you're a good student, you probably have some other good habits. If you're a certain age, when you're certain ages, you have a higher percent of those age groups that have accidents, right? So they would put how much money they could pay out, the probabilities of those happening, and they could figure out how to set your premium. And how do they set it? They figure out the expected value that they're going to have to pay out, and they set the premium above that, so they make some money. And that's how any insurance really works. Right? It's crazy. So they're always, what are they always doing to change the premiums? They're always checking to see, are the probabilities of these things changing? I have to make that into account. Are we paying out more or less money based on the cars and how much it costs? They got to change that. So they're always kind of seeing how much can we get away with where people will still want to come to us because our premiums are decent, but we're still making good money. So there's that balancing act to do, right? This is the underpinning math behind all of that. I love it. Okay, so any questions from that? And out there, that's section 4.1 and 4.2, if I remember correctly. Let's see here, Jeff's memory. Because the last thing we're going to do today, I think, is 4-3. Yeah, cool. That was section 4-2, basically. I like it. So we're going to do a little bit of 4-3 stuff. Get out of there. Stay with me now. Okay. So let me start off by reminding you guys about a probability that we've done before. So remember that problem on the such a long time ago. Is it this one? Yes. Number 3 from the practice quiz. Okay. I want you to notice something. Do you see how very specific I had to be with this question? Right. In fact, I think we're going to build this using this. So just to write some of this stuff down, the probability that somebody disliked it is 0.33. So the probability somebody liked it, 0.67. Is that cool? So I say the probability the first 2 disliked it and the third one liked it, right? That word but is kind of like a secret and. Okay. If I just said, I pick 3 people, what's the probability that one of them likes this plan? Why is that not enough work? If I said I pick 3 people, this is a different problem now. Pick 3 people, what's the probability that exactly one of them likes the plan? That is not enough work up there. Why not? How many ways? So if I have 3 people, right? You 3, right?
You 3.
If I have 3 people, how many ways could one person not like the plan? Could be her, or him. So the one we did up there was him, right? The last one. DDL. He likes it. So that's not including DLD or LDD, right? So if I want exactly one to like the plan, can I make a list of all the ways that happens? Yes, one way is dislike, dislike, like. Is that cool? That's one likes it and the other ones don't. Or DLD or LDD. Okay. So can you imagine if I had 12 people, and I'm asking probably that exactly 7 of them, do you understand that this list would get stupid long? I mean stupid long. I love the word stupid as an adjective. Are you with me? Stupid long. We're using it in a different form. What am I trying to say? This is only one, so once I kind of flow them through, I'm done. But if I had 12 people and I want 7 of them, maybe it's the first 7 and the last 5 don't. Maybe it's the middle 7. Maybe it's the last 7. Maybe it's the first 3 and the last 4. Maybe it's the first 3, the middle 2, and the last. Holy shit, right? So there will be one idea related to how long is the list, and I am not going to make you do the freaking list ever, really. I'm just doing it right now to show you the work behind it. I'm going to make the calculator freaking count how long the list would be. That's the one part of the formula I'm going to let the calculator do. And that should be like a big thing for you. Like, holy shit, this guy's actually going to let us calculate. Yes, that's the one thing I'll let it do. Help me out here. Let's do this. Before I plug numbers in general, what is it? Well, shit. Let's just go with this stuff. I'll bring it back later. All 3 of these. Now, real quick, what am I doing with each of these? This is kind of a weird question, but what did I do to figure out that probability? I put the numbers in and then I did what? Multiplied. And why does it make sense to multiply? Because what does this situation mean? The first one doesn't like it, and the second one doesn't, and the third one likes it. So and is multiply. Or, so that means I'm going to, or means add. I like it. So mathematically, what is d times d times l? What is d times l times d? They're all freaking what? They're all, what's d times d? D squared times l. Aren't they all that? I like it, right? And how many of them are there? 3, because I'm going to add them, right? So I get d squared l plus d squared l plus d squared l is 3 d squared l. And the one little thing I don't like about what I'm doing up here is these are all like probability of d, but I'm just trying to not have too much written up here. Okay, so look how this makes sense. That's power of 2, and this is a power of 1. Why does that make sense? Because I wanted exactly 1 to like it, which means there must have been 2 disliking it, and this number is just how many ways to do that. So I'm going to let the calculator do this part when they get stupid big. And when I say stupid big, I mean in the millions. Right? Have you ever heard of how many pizzas can you make? And you're like, if you're allowed like 11 different toppings, and it gets into the millions, and people are like, no. Yes. Because all the different possible combinations, it gets a lot bigger than you might think. It's insane. You're like, oh yeah, I get pretty hungry, but shit. All right. So let's start over a little bit. Let me kind of show you how to put a problem together, and then I'm going to make the general formula for this. What this is called is how many possible outcomes are there for a person? How many possible things could they say? How many? They could either like it or not. You with me? Right? We didn't give them like a spectrum. On the spectrum, where are you? No. You like it or you don't, right? So there's 2. And like a bicycle has 2 tires. Bi, and then we use the word nomial for names of things. So binomial. This is called a binomial probability distribution. There are 2 outcomes possible. There's a certain set number of times I do something. Ask 3 people the same question. That's a set number of trials of 3. And what's got to be true about these 2 probabilities? They have to add to be 1, because they're opposites of each other. Right? Okay, so let's try a different situation. You guys know what Brussels sprouts are?
Yeah.
Thank you. Anybody know and anybody like Brussels sprouts? Okay. 1, 2, 3, 4, 5. About 5. Okay. I counted earlier. There's about 30 some odd people here. So let's say the probability that somebody likes Brussels sprouts is 16%. You're gonna knock the wall, man. So it's probably that they don't like Brussels sprouts. %. Because of course these 2 have to add up to be 100% or 1 is a decimal. So let me first, there's way too many freaking words up there. The math person's going to go, ooh, shit. Even though I'm the one who wrote it. So I use the letter P for probability of success. Not just me, just every freaking person. We use the letter P for probability of success. I'm going to call a success liking Brussels sprouts. Even though I don't like it. So success doesn't have to be a happy thing. It could be a dead body, whatever you're looking for, right? Rabbit, squirrel, maybe connected to the dead body. I don't know. So what is P? It's 0.16. Is that cool? And remarkably enough, Q has nothing to do with bind your P's and Q's, but we use the letter Q for probability of, in general, that's success, so the other one must be failure. Probability of failure. So in this case, Q is 0.84. I like that. You almost never put a percentage number into an equation. Math wants the real number. Percentages are shit that we made up. Now, to be honest, we made up every damn thing. But 0.16 is an actual number. 16%, we just made that shit up to make it easier to think about. Okay, I like it. That representation. 16% is 0.16, but it's a representation we made up. So what if I pick? I pick, let's say, 5 people. And I want to know the probability that exactly 1 likes Brussels sprouts. Yes, no, Brussels. It's a little unfair. Sprouts. Yeah, Jeff, you can pretend like you can spell. Okay. Does everybody understand the basic idea? So for a binomial probability to be what I'm working with, I have to have a number of trials. In this case, it's people. It could be questions on a multiple choice test. It could be car exams, trying to drive, and so forth. A set number of things, times you're doing something. I'm going to ask the question 5 times. I have to have a number of successes I'm looking for. And my probabilities have to be opposite of each other. Success and a failure. And they have to add up to 1 because they're opposites of each other. Okay, so if I pick 5 people, probably exactly 1 likes Brussels sprouts. So I'm going to use these letters now because they represent the probability. This is a little bit cleaner. What's one way I can have 1 person like the Brussels sprouts? So I pick 5 people. What's one way that 1 of them can like the Brussels sprouts? Maybe the first person. Maybe the first person likes them, and then the other 4 don't. All right, that's one way. The first one likes them, and the other 4 are like, yeah, you go now, you can have them. Or, what's another way? Maybe the second person. All right, I think everybody gets the idea, so just to power through this, I just kind of float that P through, right? That sounds weird, but we'll get over it. Now this is a situation where I could still see the list. I'm not ever going to make you make the list, but I want to show you an example. I can see the list. If I made either one of these numbers much bigger, that list gets way too big to try to handle. It's just 1 I got to float through. That's why this is easy. If I had 18 people, I'm floating through 6 of them. Holy shit, I could split them apart. I could put part of them here, and well, holy crap, there's just way too many ways to do that. Now, mathematically, what is this? What does each one of them look like? P times Q to the 4th, because I have 1 success, 4 failures. 1 success, so the rest are failures. And of course, how many do I get when I add them all up? I get 5. So this would be 5 times, what's P? 0.16 times 0.84 to the 4th. See if you can get that in an old calculator. Let's see if we get the same thing. Oh yeah, I forgot to do What do you guys get? Yeah, I think I get what you just said. Where's the sweet spot there? No. Okay. Oh, I love this thing. Okay. Yeah, I got 0.398 to blah, blah, blah. 5 times 0.16 times 0.84 to the 4th. Is that cool? So let me show you, let me ask a different question and show you how to do this fully on the calculator. What if I pick, like I said, 18 people? What's probably that exactly, yeah, let's do like I just said, exactly 6 like Brussels sprouts. So here's the thing. I'm going to leave the first part blank. That's related to how long the list is, right? I got to show you how the calculator can do that for us. I really am curious. Do you guys understand? Now some of you guys will be like, I didn't want to make that list. But you all agree this is a very easy list to handle, right? If I was going to force you, you would pick this list to do. Because this list, you understand, hopefully you do, how stupid long this list would be. And we're going to see in a minute. We're going to have the calculator tell us how long that list would be. Because that's one thing calculators are good at is freaking counting shit. That's what they're built on. But what goes next? So how many successes do I have, and what's the probability of success? 0.16, and how many of them do I want? 6. And then failure is 0.84, and how many of them do I want?
0.
How many failures?
12.
12. I love it. Some of you guys are like, how would I know? Well, if I want 6 successes and there's 18 total people, I must want 12 failures. Yeah. What's got to be true to be these two powers? They have to add up to be the total number of people, or total number of whatever it is I'm looking at. Now, the only thing I haven't shown you yet, so this is related to this and then consolidating them algebraically. I just went there directly. Shit. If the power is how many of each I want, I can get that from the question. I want 6 successes, the rest failures. Nice. So the only thing I don't know is how long the list is, and I don't want to make the damn list. Let me show you in the calculator how that works. Was this the one that didn't have it? Let's see if I can move over to this thing. Nope, you don't have it. You suck. All right. Let's see. All right, I can maybe deal with it. Okay, there. So the way to do this, the symbol that's used to figure out 18 people, if I choose, now let me just write this, let me see if you guys, just to get used to this. What I want to do with the 18 people, I want to choose 6 of them to like Brussels sprouts, right? And really what I want to do is see how many ways from 18 people can I choose 6. So here, how many ways from 5 people can I choose 1? 5 ways. First, second, third, fourth, fifth, right? So if I have 18 people, how many ways can I choose? 6 of them. Well, let's see how much that is. Let me show you where to go for that. So let's put in there 18. Holy crap. Don't stray from your sweet spot, John. Then you want to go to math. Math. Is that cool? See the little math button? And then you want to go over to, what do you think? Probability. That's crazy. So we go to probability. Do you see which one I'm going to use now that I've...
Number 3.
Yeah, number 3. That's the one with a big C. That means choose. It actually means combinations, but I like to think of it as choose. So I've got 18, choose 6. Now yours might not look like this on your screen if you have an older calculator. That's fine. You just put 18, and then I think they put NCR in there. Is that right? Mm-hmm. And then you just put 6. Enter. We should all get the same number. So if we made the list, it would be 18,564 entries. The same way that list over there was 5 entries, right? Okay, I like it. So this is related to, like, if you had 18 toppings, then how many ways can you create a pizza that has 6 toppings? 18,564 ways. Oh, holy shit. Way more than you would think. So that's what I put right there, 18,564. So then you just throw that in the calculator, and it tells you that probability. So 18,564 times 0.16 to the 6th over times 0.84 to the, 12? And I get that, like almost 4% chance. 0.0384. Almost 4% chance that I would get exactly 6 people that like Brussels sprouts out of 18 people. Now this type of math, this type of probability process is related to a situation that anybody ever flown on a plane? Anybody, really? Just that many? I'm sorry. Man, you guys got to get around more. Or you're like, I don't want to go up there. I want to drive my corner to Hawaii. If you've flown, have you or do you know somebody who's been bumped? You know what bumped means. If you don't, you're lucky. And all of you are lucky. Holy shit. You know what bumped means, right?
No. Have you never heard over the, if somebody will give up their seat, we'll give you $200 and blah, blah, blah. And then about 5 minutes later, if somebody will give up their seat, we'll give you $300 and blah, blah, blah. You know, they're just waiting to see what level and everybody's gambling. I'll give my seat up. Let me see how far. Come on. It's $500. Somebody took it. Shit. You know, so it's, and the reason they do that is that you know that airlines, they sell more tickets than they have seats on the plane. Why do they do that? Because sometimes people don't show. There's a probability that people won't show. And what is an airline? What's the best way for a plane to operate? An airline to operate a plane is that plane is full because it's going there. So what do they want? They want every seat filled because that means every seat's generating money. The more empty seats, those seats aren't generating any money. You with me? So that's why they have to balance. It's very interesting. This is kind of related to the earlier one. They have to balance PR. If they have a lot of bumps, they get bad PR. There's articles about whatever, right? Or if they don't do it enough, they're not making as much money, right? So they have to have people that analyze the probabilities that people won't come, and they have to kind of play off. This time you can sell 2 more. This over here you can sell 5 more because that route, for some reason, a lot of people don't show up. So they have to play the numbers game. It is a bit of a gamble, right? I like it. And you're like, well, that sucks. And I'm like, well, that's the way we set shit
You
up.
recommend us to give our seats up?
I don't know, man. That's up to you. So most of the time, I'm like, I just want to get home. Shit, I'm not going to. No way in hell. And then they can drag me off. I'll be on YouTube. All right. Okay, so if you look on the back of that answer key for the double quiz, I'm not going to do this to you right now. Don't freak out. But if you want to try these out on your own, we'll do this side next time. Anybody else need one of these? The answer key for the practice, the double quiz practice. The other side is an example problem related to binomial probabilities, section 4.3. Otherwise, I think that's plenty for today. And many of you are like, yeah, I was there about an hour ago. Okay. So don't forget that quiz first thing next time. All right, and then so in general you put the, what was it? You put whatever the number is in first, and then you do add probability. Enter, and then you put 6. 18, choose 6. Yeah. Okay. So unity and mutually exclusive. So we know this. I like it. And then they ask you this, but what's the formula for it? Yeah, because you have to, because otherwise you don't know how to create this. So the formula for this would be, the formula for A given B is A and B over B. So this one would be U and V over who cares really, because what is U and V? Probability is. So this will come out to be 0. Cool. Same thing with part C. You write the formula for it. Well, U over V, remember, is U plus V. Probably U plus probably V minus probably U and V. So we know that that's 0. Yeah.
So I have the corrections for the quiz.
Right there. That's good. Thank you.
Sir,
Yes.
I wanted to pass by office tomorrow as possible.
Yeah, yeah. So on Tuesday,
Tuesday, I see it's 11 to 1.
11 to 11:30.
a.m.
To the library real quick because I need to use
After 1, you're not there?
I'm not there 11 to 1. That's for damn sure. I'm there from 11 to 11:30.
11 to 11:30?
Yeah, yeah. If I'm remembering correctly, tomorrow's Tuesday. 11 to 11:30. Yes. It's all in the syllabus. Yeah, yeah.
Oh, okay.
Look at the other hours too, and if none of them work, just shoot me a few options because I'm in the office more often doing work. And if I'm at the same time you suggest, I could tell you, yeah, come by this time. Yeah.
Okay. I was wondering how to take the test. tomorrow or Thursday. The quiz on
Oh, the make, you missed the last,
No. This quiz on Wednesday
oh, okay.
because I have to go to college for that.
So you're gonna miss class Wednesday.
Yeah.
All right, so then
Possibly.
what I'll do is shoot me an email,
Okay.
and just when I get a makeup quiz made, I'll tell you what number to call to make an appointment. It's good. They always are done through the assessment office.
Oh, okay.
Yeah. But if you don't miss class, hey.
Yeah.
Okay.
Oh yeah, I just wanted to know if you were pushing the homework for section 3 to the test.
I think I said.
I'm
I think I
sorry.
did say no. It's okay. Not today, but I think I did say the homework due the day of the next test. But you should have enough of all the sections done to be ready for the quiz.
Okay.
Yeah.
Thank you.
Mm-hmm.
Did I have an extra worksheet?
Oh yeah.
Oh,
This one, or this.
yeah. Well,
Both of them.
yeah.
I think this is from before. Where's the one? Yep. Wait a minute. I got them right here. So this is that one. And then, oh yeah, this is it. The one with the answers on one side. Yeah,
Yeah,
this guy.
you see that.
Okay,
Thank you.
sure.
I had a question. So when I put in the calculator, it gives me this. And on the quiz, do you want me to put this? Because I don't want to get wrong.
Well, you know, on the quiz, I'm going to say round to 4 places, so that's beautiful.
So there's basically it's like whatever it gives me on the calculator, I'm just gonna put it.
Round it. So like if it was 0.57148, you would make it 0.5715. You know, just make sure you round. Don't just cut it. You got to round it.
I know, but like,
Yeah, so you're good as long as you round it to 4 decimal places. All good.
but if it's like if your answer is 3 and then my answer is 4, you're gonna mark me wrong.
If I said 3 places, and
No. I'm still gonna have the decimal right here. It's gonna
Sure.
be 4 places, but this number is gonna be different than yours. The last number, you're gonna mark me wrong.
if you do that enough, because that just means you didn't round correctly. So if you only do it once, it's no big deal. But if you do it like 4 times, you're gonna
Like
take,
4
you're gonna take a
okay.
point off or something. Yeah, nothing major, but I'm like, you need to know how to round, right? Okay.
Well, yeah, I might have to lose. Those are easy, stuff. And then I know how to do this, but for this side, for basically, it's saying that this like I did this right, so I got this. So basically, this answer I just 1 minus this answer, basically. 0.
Yeah, all 3 disliked is the opposite of at least 1 liked. So 1 minus the opposite is the question mark. Yeah.
And
exactly.
then I should never get a negative answer, right? And like
Never.
This, never, right? Well, no, when I add
When you do that,
add
never.
right?
Because that's when people do 1 minus this, which makes no sense. That's percentage, so it should be 100% minus this.
Okay.
And then that would be like 96%, right?
Yeah, and
If you get a negative, you know that's probably what you did.
All right, thank you.
That's part of the homework.
Oh, cool.
So I updated